Another property of the exponential graph is that however the axes are labeled, the ratio of the value of the exponential function, that is the y value, to the slope for any point, and by that I mean the slope at the tangent line of any point, okay, that the ratio of the slope of the tangent line to the value determines something about the exponential function, and that the ratio of the slope of the tangent line to the value of the function is the same for every point. So let's see how I did with this graph. Okay, now I added a couple of points on this graph, so I've got another slope to estimate there, and I estimated that slope to be about 6. Okay, well, the first slope I estimate to be about 3. The second slope by this triangle I estimate to be about 6. The slope corresponding to this triangle, which corresponds to this point, I estimate to be about 0.8. And the slope here I estimate to be about 6. I don't know where 0.16 came from, but it is getting late, so it doesn't really give me an excuse, but what the heck. Okay, I can't find a good place here. But I'm going to say that slope should be about 6, the way the tangent line is drawn. Okay, and the y values of those points, well, this slope 0.3 here corresponds to this y value. If this is 1, then this is 2, and this y value I estimated to be about 1.5. Okay, that's a reasonable estimate. The y value corresponding to this slope triangle would be this one, and that looks to be about 2.3. And for this triangle, it appears to be, well, this is the point, and the y value appears to be about 3. And then over here, the y value has gone all the way up to about 8. I'm not sure about that tangent line because the student kind of extended the line there, so I'm not sure about this one, and I'm not sure about this one. It goes a little beyond this curve as I drew it, so let's stick to the curve as I drew it. Now we could always go to this point, and I estimate that the slope here, this is about 1.6 times this, and the y value at this point is about 1, 2, 3, 4, 5. So I could say maybe there's a point there, find a piece of chalk, where the slope is 1.6 and the y value is 5, and then the slope divided by the y value. Now we don't get really constant results here, but 0.3 divided by 1.5 is 0.2. 0.6 divided by 0.23 is 0.27. 0.8 divided by 3 is about 0.27. 1.6 divided by 5 is about 3.2. And let's forget about that age 6 because that's just a little hard. The graph is getting too steep to make a reasonable estimate of the slope. Okay, so we have these numbers here, and that's not 3.2, but 0.32. Okay. Well, these numbers seem to be increasing, which doesn't give me a lot of confidence that the graph I drew is really exponential. I think the slope might be increasing too fast for an exponential. But if we say, okay, average these x values, now when I had this other value here, which is wrong, I thought that the slope might average out to about 0.24. I'm going to modify that and say, based on this, looks to be about 0.27. Okay? Now, for reasons that you won't understand and don't need to, that means that this graph would be approximately e to the 0.27x, so that if you evaluated e to the 0.27x for x equals 1, 2, 3, 4, 5, 6, 7, and graphed it on the same graph, you would come out with a graph that's pretty close to this one. So the main point of this little blurb is that the slopes and the y values should be in constant proportion if your graph is exponential. And so a little bit related to that, people misuse the word exponential all over the place. I see it even sometimes in semi-scientific journals. People don't understand what exponential means. And then they apply it to power functions, or they apply it to anything that they feel increases rapidly. Okay? And that's kind of mathematically and scientifically illiterate. So you're not going to remember this, and you might repeat that error, but at some point you might have enough command of the mathematics, as you would after a good analysis course, high school analysis course, that you wouldn't make that sort of mistake. You wouldn't misuse the word exponential, because you would understand what it really means.